Today we're looking at page 198, number 8. We are going to use the discriminant here to determine whether or not the function has this value of y ever, which means at this value of y, if we have a real solution, or if we have one solution or no solutions. So we're looking at y equals 3x squared plus 10x minus 1. And we're going to look for when y equals 6, is what the problem says. This is the first one. So if y is 6, we can just replace 6 with the y value. So we have 6 equals 3x squared plus 10x minus 1. And then every time we find the discriminant, we have to have the function equal to 0. So we can subtract 6 on both sides to get 3x squared plus 10x minus 7. And then our discriminant is b squared minus 4ac. So our b squared is 100 minus 4 times 3 times our negative 7. This is 28. 28 times 3 is 84. So we have 100 minus 84, which gives us 16. Now, a discriminant of 16 tells us, first of all, that there are two real solutions. And also it tells us that since we have a perfect square here, that this is also factorable and the solutions are rational. We can just give this piece of information. Let's look at 8b next. And that's where y equals negative 4. So once again, we go through, replace the y value with negative 4. That's minus 1. We go ahead and we solve. We add 4 to both sides, so we have 0 equals 3x squared plus 10x plus 3. And we do our discriminant again. B squared minus 4ac, saying if there's any possible answers to this function when y equals negative 4. So we have 100 minus 4 times our a is 3 times our c is 3. And then we have 100 minus 36, or 64. That tells us that there is a solution here, and it is a real solution, or well, that we have two of them. When going ahead and writing here, I was realizing that I made a mistake up here in A. I have negative 4 times 3 times negative 7. The negative times the negative will give us a positive 84 here, so really we have 184. Since it's still positive, we still have two real solutions, but since it's no longer a perfect square, they would not be rational. You'd only be able to solve this with the quadratic formula. Whereas down here, because it's a perfect square, not only do we have two real solutions because it's positive, but we also have something that is factorable up here.